Sidecars in Kubernetes are absolutely amazing. They change the game. They change how we define our application systems and many other things. They allow us to decouple the business logic of our applications with the other things, whatever that something is. If you need mutual TLS, hey, we put a sidecar instead of embedding certificates into our application. If you need to secure our applications, again, sidecars will secure them. If you need to monitor traffic or collect data for observability, again, sidecars. They're amazing, but they're evil. They are the reincarnation of evil. Maybe not that hard, but they're not good because they consume a lot of resources, or at least more resources than absolutely necessary. They add the complexity to our systems, they add instability to our systems, and so on and so forth. And that's where eBPF kicks in. But you already know all that because you watched that video over there, right? So I'm not going to explain how eBPF changes the game and the benefits of eBPF and so on and so forth. Instead, we're going to go through a practical implementation of eBPF, in this case related to networking. Let me ask you a few questions. How do you know which service is communicating with which other service? How do you enforce the rules that enable one service to talk to another and not talk to some other tools? How do you put security in that place? How do you observe the network and the communication between your applications? And so on and so forth. I can continue with those questions, and the answer is probably clear. If you watch my videos, you would say, hey, we can do service mesh like Linkerd or Istio, and that's absolutely true. We can put some policies in place with Kyverno or OPA Gatekeeper, and so on and so forth. But all those, or majority of the solutions require us to run sidecars one way or another. We have to attach additional containers to the container of our application to make that happen. Now, if you watched the eBPF video, you already know where I'm going with this. How about we get rid of those sidecars, of those additional processes, and use eBPF? And we're going to do that with Cilium today. Cilium claims that it can do all those things. It can serve as a network driver for our cluster, as kind of a service mesh, as policy enforcer, and quite a few things. Now, whether that's true or no, we are yet to see. For now, let's explore Cilium in more detail, and to do that, I need to find a chair, a table to open my laptop. So let's go and find a place to sit. Let's take a quick break, because I want to tell you about Robusta, who is the sponsor of this video, but don't fast forward, because I know you know about Robusta, you know that it is monitoring and alerting system, and you saw my video about it, and you know that they are sponsors in previous videos. But what I want to tell you today is that they made a chatbot based on ChatGPT, and it's an open source project. There is a GitHub repository, and you might want to check it out. It allows you to communicate with ChatGPT through your Slack when you receive a notification from Prometheus Alert. And hopefully it might help you solve a problem that caused the alert in the first place. Check them out, and by doing that, you're helping this channel. Thank you so much. Now let's go back to the main subject. Okay, I'm back from my walk, and now we can go through a demo. And we are going to start by going through a couple of features of Cilium. The first thing I'm going to do is deploy my application with kubectl customize, etc., etc., etc. And that will be an application written in Go that connects to a database, in this case, Postgres database. Next, I will use curl post to send data to the application that will be inserted into the database. I will do that twice, and then I will do curl again, in this case, to retrieve the database through the application from the database. And in that way, I confirmed that I can access the application itself and that the application is connected to the database. Now, there are two ways I can observe the communication going between one service and another, or any type of service in my cluster that is using Cilium. And the first way is through a CLI. I can execute Hubble observe -- namespace, in this case production, and that gives me an output in my terminal that shows all the communication, all the connections and HTTP requests that were sent, that went through services in that namespace. Now, that might not be most user-friendly or easiest or best way to observe network traffic, so we're going to switch to a web UI called Hubble, which is part of Cilium. And I can easily access it by executing Cilium Hubble UI, and now I have network traffic through a web UI with pretty colors and buttons to click and all the things that people like when they use graphical user interface. And here we can see at the bottom that traffic, which is my ingress, goes to my application, and from my application it goes to the database, and Hubble gets confused a bit here and thinks that it goes from the application to the outside world, which might or might not be true. We might check that later. Anyways, here I can see the traffic and how all the services, all the applications, processes are connected with each other through HTTP or TCP/IP requests. Now let me stop the web UI by clicking Ctrl+C, and we can go to the next section. I want to explore how we can enforce policies for ingress, for incoming traffic. Now, don't get confused when I say incoming, that's incoming to the service, which might or might not have to be outside traffic. It can be incoming ingress traffic within the cluster. Now let me execute kubectl namespace production and output all the services and ingresses that I have in that namespace. I don't have much, but enough to demonstrate how policies work. You can see that I have the service for Postgres itself, actually two services for Postgres, and I have one service for the application itself. Now the application, as you saw in the previous section, obviously can communicate with the database, and that's what I want. That's a good thing. But what I want to see now is whether other processes within or outside of the cluster can access that same database, because if they can, then that's a bad thing. That database belongs to that application and nobody else should be able to access it. So I'm going to execute kubectl --namespace production, not so silly demo, and so on and so forth. This command will create a new pod with Postgres, mostly because I need Postgres client. And if that separate pod that is completely unrelated with the application can access the production database, the database itself, then I'm in big trouble and I should be able to do something about it. So I'm now inside of the container, a new container, and I'm going to execute psql, specify the host and everything else, and there we go. I'm connected through psql client to the database, even though this container is not the application, is not the one that should be able to connect to the database. This is a big security breach. And to demonstrate that I'm really connected to the database, even though I shouldn't be, I can, for example, do \l to list all the databases, and hey, here are all the databases in that database server. I'm going to try to create a database, not silly demo, a separate database in that server, and that worked as well. You don't believe me? Let's list all the databases. And there you go. You see, the database is there. Fortunately for me and you, I can fix this. And to do that, first thing that I'm going to do is exit that container, because that container shouldn't be able to do that in the first place. And I'm going to create a Cilium policy. Actually, I already created one. So let's take a look at what we have. To begin with, there is endpoint selector that instructs Cilium to know what is the endpoint that should be secured in this case, or that some policies should be enabled for. Then I have the ingress section that has two subsections. The first one is from endpoints that specifies that my database, silly demo, can access the database. Anything else shouldn't be allowed to access it. And since I want my application to be able to access only a specific port of that database, I have two ports section that says, hey, it's 5431, 32. Now let me apply that definition with kubectl customize and so on and so forth. And you can see that network policy was created, and hopefully my database is now secure. And I can test that in two ways. Actually, I will apply both ways. First of all, I'm going to check whether some other entities, some other containers can connect to the database or no. And I also need to double check that my application can connect. So only my application should be able to connect to the database. So let's start with the first use case. Can some other process, some other container, inside or outside of the cluster, be able to connect to the database? The answer should be no, if I did my job well. So I will execute kubectl --namespace production and so on and so forth. The same command that I executed before that will create a new pod with a container with pSQL client, and it will try to connect to that database. So I'm inside that container and I can execute pSQL command with the host and all other information required to connect to the database, and let's see what happens. Nothing, nothing, nothing. It keeps hanging, and it will keep hanging until the timeout because it cannot establish the connection. Either I can wait or I can stop. In any case, it will not connect to it, and eventually it will reach a timeout, which I do not want you to wait for. So trust me, I cannot connect to the database except if I'm a silly demo application and I know that I'm that application, not through labels in this case. I could do a better job of securing it, but labels worked for now. Now, it would be silly if I created a policy that denies anybody to access to the database. I do not want that. I want my application to be able to access it, but nobody else. So I already confirmed that nobody else works, nobody can connect to it, but now I need to confirm that the application is still working, and I will do that by sending a request, CURL request to my application, and there we go. You see the output. My application is still able to communicate with the database, but nobody else can. Simple policy, very effective. Now, what we saw in the previous section was how we can enforce incoming traffic to be allowed only from certain sources. But sometimes we want to prevent egress. So previous example was Ingress. Now I want to see whether we can prevent egress, outgoing communication to certain services. So what I want, actually first I'm going to check whether my application can connect to random addresses. So I'm going to execute CURL to silly demo application, and I'm going to go to /ping because my application already has code that allows me to pass the address of external service, or that my application contacts that external service. It's a silly ping service. Anyways, I'm going to see whether my application can access DevOps and here you see HTML output of DevOps so my application, silly demo, can access it. Let's see whether the same is true for, let's say, Google. Can I access google.com? So another CURL request to silly demo, and I want to ping google.com, and the output is, again, there. It's HTML of google.com web page. In other words, my application can access any external service, which is not good. There is no good reason why that application should be able to access both devopstoolkit.com and google.com and anything else on the internet. I should be able to specify, to define a policy that says, hey, those are the external services, those are the egresses that you should be able to access, and everything else should be denied. So let's take a look at yet another policy and see how easy or hard it is to define egress. So this is yet another Cilium network policy, and just as the previous one, it has endpoint selector that specify as the application or the processes, the services for which this policy should apply, and those services, that service is the silly demo service. What is new is the egress section. Previous one had Ingress, this one has egress section, and within that section we have subsections. The first one is to FQDNs that says, hey, you can access devopstoolkit.com or any subdomain of that domain. That's okay. You should be able to access that external service. Then I have the first out of two endpoints that says, hey, anything within this namespace is also okay. You can access other processes within the same namespace. And the second two endpoints says, yeah, you can access kube system as well. Now, whether that's a good idea or not, doesn't matter. That would be a separate discussion. But in this case, you can access those as well. But it's not the whole kube system namespace. That would be silly. It's only Kubernetes app kube DNS in that namespace, because you might need to discover DNSs of other processes in that cluster, right? And finally, there is two ports section that has two entries. One says port 53 on any protocol, that's for the DNS, and the other one enables any DNS, essentially. So first thing first, I'm going to apply that policy by executing kubectl, customize, and so on and so forth. And now the new policy should be working, should be in effect, and it should deny access to anything but DNS server within the clustering kube system and DevOps Toolkit series service, which is external to the cluster, and the third one should be anything within that namespace. So let's start with DevOpsToolkitSeries.com. Can I access that service? The answer should be yes, but let's double check by executing curl, and then I want to ping DevOpsToolkitSeries.com, and the output is the HTML. So that works because I specify that I want to be able to access that external service. But what happens if I try to ping google.com? Well, nothing happens. It hangs and it hangs and it hangs, and I will stop it from hanging because it will continue hanging until it reaches a timeout. In other words, I cannot access google.com or anything else outside of the cluster except DevOpsToolkitSeries.com. Now let me double check whether I can still access other processes within the production namespace by sending curl request to my application, which will talk to the database, and you see the output. That works. Now, there are many other features of Cilium, but I do not have enough time to go through everything that Cilium does. Instead, I'm finished with sharing my screen, and I will go for another walk and tell you about the additional features in a nutshell, and then we'll talk about pros and cons. Cilium is first and foremost networking and network policy solution. However, it has so much more. There is cluster mesh that enables us to mesh services across different clusters, but it's not so great, at least not yet. There is a service mesh similar to Linkerd and Istio, except that it is based on eBPF, but that one is not baked well yet. It's fairly new. There is also Ingress, but you know the answer, right? Not yet there, not yet great. It is a bit finicky to set it up. Finally, there is integration with Prometheus and Grafana, which actually is great, mostly because Hubble is, not there yet. I will not go through all of those because that would take too much time. Instead, let's talk about pros and cons and figure out whether you should be using Cilium or not. So, Cilium is a networking solution, it is a policy engine for networking, and it has additional capabilities like those that are usually seen in service meshes. So, can it replace sidecar container-based service meshes like Istio and Linkerd? No, nope, not today. Is it a replacement for service mesh? Again, not today, unless you do not need all the features of service meshes, which might easily be the case. But here's an important question. Will Cilium or some other eBPF-based solution be a replacement for service meshes in the future? Maybe, likely, most likely. I think that that's where we are going. Service meshes will get rid of sidecars and start using eBPF. And we already see the signs for that in other projects like Istio. Now, you likely do not need all the features of service meshes, and in that case, if Cilium gives you what you need, it could be a great choice. Actually, a fantastic choice, if what it has is what you need. But right now, Cilium should be used if you need a networking solution with amazing policy engine. And it is also going into the right direction. It is likely going to be the dominating product in the market, at least when service meshes are concerned. Now let's go through pros and cons. Now let's start with negative things, cons. To begin with, installation is finicky, sometimes painful. It's not as easy to set it up as other solutions, mostly because eBPF is still new and operating systems might not be prepared in all the vendors and so on and so forth. Hubble, the UI is rudimentary and it can be improved greatly. It's also a relatively young project, so I expect it to become great. But right now, Hubble cannot replace things like Jaeger, for example, or Grafana Tempo that gives you the tracing information and communication and graphs and all the things that you normally use. Now, that's not a big deal because you can hook it into Grafana and create your own dashboards and then somehow mitigate the problem with Hubble not being there yet. Finally, and this is a big one, you might not be able to set up Cilium in an existing cluster. You might need to create new Kubernetes clusters if you want to use it. which might or might not be a problem for you. Now let's go into pros. Let's see what are the positive things about Cilium. The first and the most important thing is that Cilium is based on eBPF. If I'm right, eBPF will replace, for some, if not all such tasks, sidecar containers. eBPF is likely the future, and that's the main and the most important thing about Cilium. You're investing in the future. Second, it is already available out of the box in quite a few Kubernetes distributions. So if you're lucky and the Kubernetes distribution you're using or the service you're using already supports Cilium, you might be actually using it without knowing, or at least having it in your cluster. Finally, Cilium is more or less the de facto standard for networking in Kubernetes and network policies, or at least one of the contenders for the de facto standard. So the question is not that much whether you should use Cilium, you should, but whether you should extend it with its new functionalities like service meshes, cluster mesh, and so on and so forth. And for that, I would say wait for a while longer, but keep an eye on it. Thank you so much for watching. It's Victor from Florida. See you next time. Cheers.